Hello. Yeah, thanks for the introduction. Indeed, I am going to talk about a type level, and this is going to be a bit of a history talk. And just as a general note, I don't have time to cover all of Scala's history, so I'm just going to carve out that subset. A type level ecosystem, and basically starting all the way from the beginning and then arriving at today, where we are working on providing Dotty releases to the community. But before I start with the history, I would just first like to mention what type level is. So if you're doing functional programming in Scala, it's quite likely that you have stumbled over type level already. We are basically an open source initiative, loosely associated people, so there's no formal organization behind it. We try to make functional programming nice in Scala. And depending on how you count, we have at least over 60 active projects. There's dozens of people involved. This is a screenshot from the GitHub type level site, but there's also other organizations like HTTP4S or Monix that are associated with type level. So there's quite a bunch of stuff going on. And of course, the most famous library, I think, in the type level ecosystem is CATS, which is a foundational library for functional programming abstractions, and probably also Scala check. And if you're doing property-based testing, you might have used it already. Gaining momentum are CATS effect and FS2 for concurrent programming, effectful programming, and so on. So there's quite a bunch of stuff already. Yeah, so Typelevel was founded in 2013 at the Northeast Scala Symposium. This is an actual photo from this conference. We see here Eric Oschheim talking about performance and optimizations in Scala. And yeah, so that was 8 years ago now, and the ecosystem has grown quite significantly since then. Yeah, so the central theme, as I've already mentioned, is that we want to do functional programming, but we also wanted to make Scala idiomatic. So we don't want to just copy-paste Haskell standard library to Scala. We actually want to work with what the language provides to us. And we want to do that with as little hassle as possible for users. So basically, they should just import a few things and be good to go, with as little runtime overhead as possible. So even though you might be using functors or whatever, or monads, your JVM should not die because of memory exhaustion. And also it should be as safe as possible. So there should be there shouldn't be a lot of opportunities to use the APIs wrong. And of course, all of these three goals are somehow competing with each other. They can't be satisfied all at the same time, but many of the libraries try to take the right trade-offs there, with taking the user usually first. All right, so if you want to do functional programming in Scala, then what we are going to need are type classes. And type classes are really, really pervasive in the ecosystem by now. There's a few type classes in the Scala standard library also, and CATS, of course, provides the usual functional programming instructions like functor and so on. But there's also Scala check. Scala check also provides type classes, so it's very likely that you use them in some way already. Type classes are a really useful tool. That's why we use them all over the place, and they've been pioneered in Haskell. Now, Haskell has a very dedicated syntax for type classes. I have just put an example here on the slides. So you write the class keyword, which means something different in Haskell than in Scala or Java. And then you say, well, I have a type class here that's called monoid. It takes a type parameter A. It depends on another type class, which is called semigroup A, and then you have a bunch of functions in there. You can also, you can leave them abstract, or you can give some default implementations. All of that is possible. And the cool thing is it just works. It's integrated in the compiler. It's working beautifully with type inference and so on. So all is very nice. And this is a picture of the functional programming working group 2.8, what they're called. And a few of these people are also in the Haskell committee, so they came up with all of these concepts, and it works nicely for them. And here's a picture of some people in the Scala and the Typelevel community. Now we're trying to make sense of what the Haskell people came up with, right? So they have these beautiful ideas, they build it into the compiler. In Scala 2, they're not part of the compiler, so now we have to work a little harder to get them available there and make them usable. Right. So type classes are cool, now we just need to encode them in Scala. However, we soon realized as a community that there's a bunch of problems with the encoding. So what do we do if we want to do multiple inheritance? Multiple inheritance, of course, exists in Scala with traits, but if you want to get implicit search to play nicely with type classes that have like a diamond inheritance, you're going to have a very bad time. What about syntax? So you have a type class like semigroup for adding stuff, and then you want to provide a plus operator for these things. And in Scala, you have the plus operator for ints and so on, and for strings, but maybe you want to provide a plus operator for maps, because maps can also be added to it. What do you do? Yeah, and what about global confluence? So this is a very technical term, and it basically means that if you have one type class instance and you want to derive another type class instance from it, sometimes you have two different ways you can go. You can go like this way and that way. And in Haskell, it is guaranteed that both ways are the same. In Scala, it's actually not guaranteed, and we recently had a bug in cat's effect because of that, because this global confluence property was violated. So you get slightly different semantics, which is of course bad. Here's a guy, his name is Adelbert, and he thought about all of these things, and he was just very confused. So in order to get a better understanding, he wrote this paper, which appeared at the Scala Symposium. And here he basically explained what the limitations are of the common encoding of type classes in Scala. Yeah, so if you are interested, you can read this paper. It's 6 pages. It should be understandable without having an academic background. And the bottom line is really we need to play a lot of tricks to make type classes work nicely in Scala 2. And one of these tricks are macros. This is actually a picture from Mile 7 at the Scala conference, where he showed how to multiply numbers on a type level, and the audience was really, really pleased with that. So it was a lot of applause when Miles showed how to multiply 3 times 5 on a type level. Right, so, but let's talk about type classes again. In 2015, Michael Pilquist, who is also a member of Typelevel, he started the Simulacrum project. And his goal for this project was that he wants to have a consistent encoding of type class across different projects with 0 boilerplate, or at least as little boilerplate as possible. Because at the time, there were a few projects in Typelevel that had various different encodings or slightly different encodings of type classes, and they worked slightly differently. So he thought, let's standardize on one thing. And that's what he did. So he brought the Simulacrum library. It contains a bunch of macros. And you have to write a trait as usual. So here we have the semigroup type class again, and then you just slap an annotation on the trait. So you say add type class, and then you also slap an annotation on the method. So here we have the append method, and we say, well, we want to use the plus operator within these bars to distinguish it from the normal plus. And this should somehow auto-generate some code that makes it useful. Right, so this worked, and as you can see, there's very little boilerplate going on here. Just have to put these annotations there, and then for users, it just work out. Now, let me just show you what the underlying machinery is. So when you write this, what actually gets generated, and I want to emphasize that I do not expect you to understand what's going on. I just want to show you how much is going on here. So you get a semigroup object, which has an apply method. And the semigroup object also has an embedded trait. And there's another embedded trait that contains an implicit. And then you have an object that extends from this trait. And then you have another trait and another object. So all of that stuff is going on just for writing a simple type class. And this is an actual picture of Michael in the basement of the Comcast office in Philadelphia while he was devising all of that. And he's actually a hero for figuring out all of that stuff, because Simulacrum actually solved a ton of issues. It works. We can write x plus y if x has somehow an instance of the semigroup type class. And it's used by cats and tons of third-party libraries. And it kind of does a very good job of hiding all these complexities away from the user by just slapping these annotations on the type class, and it takes care of inheritance and all of these things. So that's pretty cool. On the other hand, I'm very glad that I didn't have to write it, because I'm sure Michael had to pull a lot of his hair out while trying to get this to work. Okay, so it solved a ton of issues, but it didn't solve all of the issues that we have with type classes. So in particular, Simulacrum didn't solve the performance issue. So let's say you write something innocuous like this. You add two maps together, for example, x plus y. And it looks easy enough if you type it. The question is, what does the JVM see when you want to execute it? And this is what actually happens. You go to this companion object, semigroup.ops, and then you call this to all semigroup ops, which is kind of an implicit class that provides all of the syntax. And then you do another method call, and it has to allocate at least one object. And then it has to call a method on this object. And as Scala programmers, in particular as functional Scala programmers, we often say stuff like, don't worry about these allocations and these functions calls. The JVM hotspot will just inline this, and then we just call it a day, right? So just write your code however you want, and then the JVM will magically fix all the performance issues. Of course, that's not true. That's just a lie we keep telling ourselves. So hotspot is really great as an underlying execution engine, but if we just put layer on layer on layer on stuff on it, not even hotspot can fix it. So now Eric Oschheim came along again. And in 2014, he split out a bunch of macros from Spire, which he put in there to make Spire really efficient. Basically what Machinist does is it condenses all of these calls into a single call, and a direct call to the actual logic behind it. So you don't have to suffer from that allocation cost. Unfortunately, it is not really clear how to port Machinist to Dotty yet. Nobody has put in the work yet to make this happen. The project is archived, and the relevant parts are, as of 2020, reincorporated this file. So all the other type level projects currently have to suffer from this performance penalty. And if anyone in the audience would like to get their hands dirty with that, we would be extremely happy if someone could take a look at this. Simulacrum, however, is already sort of ported to Dotty, not by using macros, but by using Scala fix, actually. So it's more of a direct code generation approach now. Yeah, so all of that is being used by CATS currently, currently CATS has the 2.x release, which is stable and is going to be maintained for a long time down the road. However, we have kickstarted the discussion on a possible roadmap for CATS 3. And one of the options that we have in CATS 3 is to use a completely different type class encoding that becomes possible by going Scala 3 only, because Dotty has a few more concepts here that can help us. And this is actually open for discussion, and there has been already some experience by a few people how to leverage these new features to make to even clean this up even further. However, it's going to be very hard, if not impossible, to maintain this for Scala 2 and Scala 3. So if we go ahead with a new encoding, it would probably mean that CATS 3 would have to be Scala 3 only. Okay, so let's take a look at another topic. So type classes like semigroups and monoids are kind of nice. They appear quite frequently in programs. And we have just seen how in the Typelevel libraries, we did a bunch of stuff to make them usable for programmers. Now, there's another big topic here, which is that there are some type classes which are a bit more complex than monoid, for example. And one of the examples for that would be monad, for example, or anything that's related to effects, because suddenly you have to talk about type constructors. So you just don't talk about simple types anymore, but about the actual type constructors. Now, what does it mean? So regular polymorphism in Scala means that we have, generics. So you can put type parameters on methods and classes. What you can also do in Scala is that the type parameters themselves, they can be more complex than just simple types. So here's a class, it's called either_t. It's directly taken from cats. And what is an either_t? It's a wrapper around an either of AB, and it's wrapped with the type constructor F. And this is something that has also appeared a few times at this conference already. So Nicolas' previous talk was also dependent on having this type constructor polymorphism concept. And Scala is the only language that can do that kind of stuff. I put an asterisk in there because, of course, Haskell, for example, can also do that. But Scala is the only language that combines subtyping and object-oriented programming with these kinds of type constructors. So really, we are in a very unique spot in the programming language community because not a single other language can do that. And this also means that we have to tackle some really unique challenges here. The type constructor polymorphism was introduced in Scala 2.5 by this guy. This is Adrian Moose, and that was in 2007. It was his PhD. And I think I do not overstate it if I say it was a complete game changer for the entire functional programming ecosystem. And like, I'm pretty sure that libraries like cats would not have happened without type constructor polymorphism, without this this contribution by Adrian. So I am really thankful for that. And as soon as they landed in Scala 2.5, people started using it for everything. And I put a quote here from which is kind of ancient Scala wisdom. And the quote says, as soon as you give Scala programmers a new toy, they will start abusing it in ways you can't even imagine. And I'm sure this is also what Adrian thought when he saw what people were doing with this type constructor polymorphism in Scala. And I have one concrete example. So as I mentioned, Scala isn't Haskell, and there are things that we can just easily do in Haskell that we can't do in Scala. So for example, we consider the either type. It also exists in Haskell. In Haskell, we can easily make either an instance of monad. So we fix the A and say, well, either A is an instance of monad, and the B can then change with map and flat map and so on. In Scala, we can't write that. We have to write stuff like this, or at least we used to have to write stuff like this. And this abomination is called a type lambda. And depending on how long you've been around in Scala, you have seen it or you haven't seen it. And if you haven't seen it, you're probably thinking, what the hell am I looking at? What is this madness? Like, why are there Greek letters in my Scala code? What's going on? And yeah, this is how we had to write it before we had kind-projector. So this is another project that was started by Eric Osheim. And what kind-projector allowed us to do is we could add syntax for exactly what we can do in Haskell, but couldn't so far in Scala. So basically, kind-projector allows you to put a question mark at some particular points and types. And then you can say, well, I have a monad for either, and the A is fixed, and the second type, the right type, it can be changed. And this really worked. And it's also used all over the place now. Okay, so now we had that. So that was cool. We could write our monad instances in peace without suffering Greek letters. But then there was another issue. And this is the magical SI 2712 issue. If you want to send a Scala programmer who's been around for like, I don't know, maybe 10 years, shivering in cold sweat, just say SI 2712. It is, I think it's the most infamous Scala ticket ever written. And why is it like that? here's an example of what this 2712 issue was about. Let's say you write a simple function, it's called foo, and it takes an f of a, and both the f and the a are type parameters. So f is a type constructor, a is a simple type. Now you want to call this foo with an either, then the compiler said, nope, cannot do that because you've supplied me an either, which is a type constructor that takes 2 parameters, but I've expected f, which just takes 1 parameter, and I can't make this happen, right? I cannot unify these two things. And a lot of Scala programmers thought, well, the compiler really should be able to unify that, but it couldn't. So another abomination was created, which is called Unapply. And just to note that Unapply has nothing to do with extractors, so it's a completely different thing. And the idea was you take dependent method types and you take tons of boilerplate, then you get a hack for this. And I'm not sure who I'm quoting here, but I think someone said that not a single line in the Scala 2 compiler has been written with that hack in mind. So really, that it worked at all was just a pure luck. And again, the next slide contains some code example, and I don't want you to understand this. I just want to show you what an abomination this was. So we define a trait that's called Unapply, and you can already see there's some interesting type parameter business going on here, lots of underscores, and okay, it's a type, it's a trait that contains some types and some defs, okay. Looks simple enough, but let's look at some of the implementations. Boom, right? So this is what you get here. There's just tons of stuff going on here with tons of type parameters, and this is just one instance. You had to define quite a lot of these instances, and it's bad. It's really, really bad. You probably don't want to do this, but it worked. 7 years later, luckily, Miles came along, fixed it for Scala 2.12, and he also built a compiler plugin that fixed it for 2.10 and 2.11. So finally, we didn't need that hack anymore. We had kind-projector for the nice syntax. We had the 2712 fix for the instantiations. Everyone rejoiced. We could finally code our type classes in peace without having to think about all these weird things. All right, so fast forward to Scala 3. I'm very grateful to the Dotty team because they have put a lot of effort into consolidate all of these type level hacks that we were doing, and in particular, type lambdas are now built into Dotty. So it's almost the same syntax as kind-projector. So you have to exchange the question mark for an asterisk, but then it's going to work. And this also allows us to cross-build a lot of our libraries between Scala 2 and Scala 3. This is a picture of Guillaume. It's from Typelevel Summit 2016, so that's been a while ago. And he gave a talk on the type system of Dotty there and what they're doing there. And I think Guillaume was very instrumental in designing the type system of Dotty and making everything work. And whenever we had some problems in Typelevel in debugging some inference issues or whatever in Dotty, so something that worked in Scala 2 but didn't in Scala 3, our usual approach was we notify Guillaume about this, for example, by opening an issue in the Dotty repository, and then Guillaume responded that he has already fixed it 10 minutes ago before we even filed the issue. So he's really great. He fixes a lot of things there, and we actually had quite a close collaboration also with the broader Dotty team on these things. There's also a paper on this, how they implemented higher kind types in Dotty. And they considered a few different encodings, and in the end, they decided to have a direct representation of all of that stuff, type lambdas, SI 2712, and so on, in the Dotty compiler, which means that now we can definitely say that the lines in the Scala 3 compiler have been written with all of these things in mind, as opposed to the Scala 2 compiler. So that actually makes us a lot more confident that the support for type constructor classes in Scala 3 is very robust. So yeah, at this point, I should just say thanks to the people at EPFL and all the contributors to making this happen. All right, finally, I would like to take the remainder of my talk to talk a little bit about macros. I mentioned them in passing, that, for example, macros were what powered the Simulacrum annotations and allowed us to generate all of this boilerplate, but it didn't actually explain what's going on there and what the way forward is for Scala 2 to the Scala 3 migration here. So the Scala 2 macros, they landed in Scala 2.10, which was in 2012, and the guy who made them happen is on the slide. This is Eugene Bermacco. And this was also his PhD thesis. And it enabled lots of innovation across the board. So many people started writing awesome stuff with macros. There's a ton of libraries out there that could do cool stuff. For example, you can use macros to provide rich assertion failures. So when you write a test and you say assert this equals that, usually you would just get the response that the assertion failed. But if you use some of these macro libraries, it can tell you, well, it failed, but it failed because this is 1 and this is 5, for example, which is really great. Unfortunately, those macros are not available anymore in Dotty at all. And the reason for that was that the Scala 2 macros were really tightly coupled with the Scala 2 compiler. But there's been a bunch of different research directions and engineering directions to pull out some of that stuff. So there's Scala Meta, for example, which is available for both Scala 2 and Scala 3, which can do some kind of insights on code. But if you actually want to do meta programming in Scala itself, something like macros, again, then in Dotty, you have to completely rewrite your code. There's new meta programming in Dotty, but it has nothing to do with Scala 2 macros. And just to illustrate this point, I have an example here from Michael Pilquith's scodec library. And in the scodec library, he has a bunch of tools for writing bit strings and byte strings and so on. And he has syntax there for allowing you to write hex and then a string, and you give a hex number, and then it gets converted to a byte string. And all of these things are different in a different Scala version. So you can see here, this is a screenshot from GitHub. You see that he has folders for 2.11, 2.12, 2.13, and then again for Scala 3.00, M1, M2, and so on. And he started this re-engineering in Dotty 0.22. Well, I mean, there were some previous versions even where the tests were not compiling, but anyway, the point is he's been taking a lot of effort to make all of this happen. But as I said, it requires a complete re-implementation. And I guess this is the strongest pain point we have currently, because, well, I mean, scodec is fixed now, cats is also fixed now, but there's a few libraries that are dependent on macros where we haven't yet found a workaround. Machinist is one such example. So Spire depends on these macros, and we haven't yet figured out how to go forward. Anyway, I have about a minute left, so I want to give a brief outlook what's going to happen for us in Typelevel ecosystem. Scala 3.0.0 is near. So I believe that the release candidate 1 is going to happen not too far down the line. Maybe Martin will say in his keynote when it's going to be released, I don't know. All the language features are there that we need. Simulacrum is there. It's now a set of Scala fixed rules. Many major Typelevel projects are already cross-building, and we have a working release train. So whenever a new Scala 3 milestone or when the release candidate comes out, we just crank all the gears to publish all the libraries. So we are actually at quite a good point. However, as I mentioned, there's still lots to do. So HTTP4S is currently in progress. I think HTTP4S uses some features that have been, some type system features that have been removed. So there's a few type projections in HTTP4S that need to be changed. Also, Monix contains a lot of macros, is not yet migrated. So if you're interested in spending some time in this, all of these projects are community-based, are community-backed. So please send us your pull requests. They can be small. So if you just bump some dependency to like try and get it to compile, maybe not the tests, but just to get it to compile, very welcome. Join the Gitter channels and ask for help maybe. And yeah, we would be very happy to see your contribution to get the entire Typelevel ecosystem and even the broader Scala ecosystem on Scala 3, because Scala 3 is very exciting and we're looking forward to it. And with that, I conclude and would be happy to take any questions now.